So what we're going to do is we need to go to the program, and we need to, where it says torque thrusters at the beginning of the program, we're going to need to put something there. So again, this is in the part where we declare all the variables.
Right, so the new variable, yeah.
Yeah, so right here, that's torque thrusters. And we want to write F thrust times L ship divided by 2.
I spelled those. Okay, good. I spelled those correctly. Okay, and that would be in parentheses, right? Or no?
If you want to. But I don't think it really matters.
Okay, because it'll do the multiplication first anyways, because it's...
Yeah, it shouldn't really matter. And then go ahead and set L ship to 100. And later on, you guys can change L ship to whatever you want, and we'll see what the effect of that is. But there you go. Okay, so now we've got torque thrusters, we got I ship, things like that. So let's go ahead and, all right. So now that we have the torque in there, so the torque thrusters in there. Let's go back to where those if statements are over here.
Right, because we have we've changed the value of angular acceleration, but we're not doing anything based on that just yet.
That's right. So what do we do with this angular acceleration variable to use it to update our value of theta? And basically, you can kind of go back to the step-by-step to kind of see what to do. Right, because there was an equation with
it. Yeah, so it equals T net over I.
Yeah, so the net torque divided by, so this I is sometimes called the rotational inertia or moment of inertia. So the more torque you have, the more that your rate of spin changes is what this equation basically means. So we already kind of used this in the if statements, but what we want to do is we want to go a little bit lower on the screen here, and we want to make sure that this equation appears somewhere. So this is the initial rate of spin, so omega here. I know it looks like a W. It's not a W, public service announcement, not a W, it's actually omega. And so this is the initial spin rate, and maybe the initial spin rate's 0, which is what we're doing now, right? Because initially the thing's not spinning.
Yeah, that makes sense.
And then I feel like I'm shooting you. I didn't mean to do that, but and then there's the angular acceleration times the time interval, right? So our times our little time step gives you the final angular speed. So that looks pretty good. And then we also have to have this equation, which is shooting you again.
So we're looking at the screen and trying to
do the matrix. So you have the initial angle omega. It's not an O or a 0. That's omega, and times the angular speed times the time interval, and then that gives us the final angle. Again, this angle is the angle that the ship is making. The angle that the ship is making with the there you go. The angle that the ship is making with the x-axis is what it should be. So all we're going to do is sort of convert those into code. So you know how to convert those into code, or did they give you the code? I wrote the thing. I can't remember what we put in there. So I'm actually, I bet you in the next step. There we go.
Yeah, angular acceleration. Yeah. So we
already got that one in there.
Okay, right. Yeah, because that was the first equation. Okay. Yeah. So this is the other equation. So the equation we just looked at.
Got to stick that in there.
Right. So omega. Okay. So basically, the way this is you're taking omega, you're adding the angular acceleration times dt to it, and then you're using that to change the value of omega. Exactly. It's a programming equation, not like a regular equation where you'd be able to cancel out omega because it's on both sides.
Right. Yeah, that's something you got to get used to with programming, is that it's not the same as a math equation. We have a whole video on the math world versus computer world.
You don't have a plus equals in JavaScript, do you?
We do. So we could. So what we can do later.
Is way better.
What we could do later is we can replace that with a plus equals, and we can show them that that works just fine.
Plus equals it.
For some reason, I felt like doing it this way. Yeah, but we'll show you the other thing.
Omega plus equals. Either one of those lines of codes would work, but I don't really want to do it twice, so I'll just comment that out.
Cool, and then make sure you put in the theta, because we still haven't changed theta yet, right? So until we add this code, it's not really going to change the angle that the ship is is pointing.
Okay, yeah, that's the same thing there. You could replace that with a plus equals instead of doing theta equals theta plus omega times dt.
Alright, so now let's try it out. And
oh, it's trying to move the web page.
okay. By the way, I don't know that this is going to work yet, and I'll tell you why in a minute. But go ahead and try, see what it does. All right, so that
is getting the arrow, but it's not actually turning. Although that
right.
And now it's gone.
Right. So here's go where the variables are at the beginning of the program.
Okay.
Where we define torque thrusters and things like that. Because remember, the angular acceleration is the net torque divided by the rotational inertia. So like the bigger the thing is, the harder it is to get it rotating, right? And so we have all this good stuff with the force of the thrusters times the length of the ship.
But I ship is 0.
I ship is 0.
And we have a line of code down here where we're dividing by it. So we're dividing by 0.
That's right. So
it must not like that.
Yeah, so in this code by my elbow, we're divided because we're dividing by I ship right there. Okay? And so that, dividing by 0 always never goes well in a computer program, right?
Yeah.
So we got to go ahead and put in something for I ship. Now I ship, if you imagine this thing is like a rod and it's rotating, if you go in a physics textbook, it will tell you that the rotational inertia is 1/12 times the mass times the length squared.
Okay. So I can just take 1 divided by 12, right? Or does it want to?
To be safe, I would give it 1.0 divided by 12.0.
Oh, okay.
There are some circumstances in which 1 divided by 12 equals 0 because it rounds it to 0.
Oh, okay, that makes sense. Yeah, so that wouldn't solve our problem at all. So 1 divided by 12 times mass or something?
Yep, times mass, M-A-S-S.
Okay, so you just call it mass.
Times L ship.
L ship.
And go ahead and try the up caret 2 thing just to see what happens.
Okay, right, because you wanted to square it.
Now this is not necessarily going to work. Okay.
Okay.
All right. So try that.
It is rotating.
Yeah.
But it's not exactly what we wanted.
Right. So go ahead and replace this up caret 2 with just a times
L ship.
Yeah. So whenever you square something, for some reason the people that made JavaScript didn't like the up caret 2 thing for square.
Okay. It's still...
So this works...
It's a little bit better, I think.
A little bit better. But there's one more thing that we have to do, which is that if you just... So go ahead and hit play and just tap on the left arrow, and then raise your hands to show that you're not...
Yeah, I'm not doing anything. Yeah, so it's just... Oh, wait, I should move so you can actually see.
Yeah.
But it's just... It just keeps going faster and faster.
Yeah. Go ahead and show him... Go ahead and try it again. Show him what it looks like.
Yeah, I'll try and stand out of the way this time.
There you go. So we're not touching it at all, but it goes faster and faster and faster until it...
It's my hands. Yeah, so it won't until game over, but yeah.
So that's not what happens in real life. In real life, if you start spinning, you're going to spin at that constant rate unless something changes, right? Unless there's some force on you. So we have to make sure that when we're not touching it, that the angular acceleration is 0.
Okay.
So that's the thing that we're missing.
So it's 0 at the beginning.
Yeah, it's 0 at the beginning.
We're changing it. Where are we changing it?
But as soon as you set
okay, so if you're pressing...
Yeah.
If you're pressing the key, right? So if... So would it just be just sort of at the end here, right? Because it'll go through those if statements and change it, and then if you're not pressing it...
So my advice is kind of more towards the beginning.
Or towards the beginning. So set it to 0 and then change it...
Right there. Yeah.
So we set it to 0 and then if...
Yeah, so that should work now. So let's see if that... Let's try that.
Oh yeah, that's much...
There we go.
Yeah, so it's just going at that constant speed.
Right. So you should only see that orange circle. By the way, the orange circle is the torque vector. And because the torque is because it's spinning, then the vector is sort of like a circle shape instead of like an arrow shape.
Right, so it shows if it's going clockwise or counterclockwise.
Right, but you should only see that circle when you're pressing either the left or the right arrow key. You shouldn't just like always see that circle.
Right.
Something is wrong with your code if you always see that circle, because
you shouldn't always be applying torque unless you're constantly pressing down.
That's right. Now
and then it does go faster.
Yeah, right. Yeah, you can still get to go pretty fast. By the way, one strategy with this game is to get going not super fast, but fast enough, and then that's a little bit on the fast side. If you get going moderately fast, and that way you can just sort of, when the asteroids come, you can sort of thrust away from them when the ship happens to be pointing away from it, because if you're spinning around, does that make sense?
Yeah, that makes sense.
That's
you
like
sort of strategically wait to press on your thrusters until you're facing the direction you want.
I used to be really good at this game when I created it, and I'm not as good anymore.
It's tricky.
Right. So, just as a disclaimer, there's a couple different ways of sort of writing this and getting it to give approximately the right behavior. This way is the one that we recommend, because the display function's expecting to see this angular acceleration equals 0, because that's how it figures out whether to draw that orange circle on there or not. Anyway.